Hello, welcome to the video. In this lesson, we're going to be looking at section 2.5, where we're going to be solving compound inequalities. So compound inequalities are essentially two separate inequalities, but what makes them a compound is a particular statement that is given to each particular situation, which allows us to use them together. So the two statements that you are going to look at is first, are you going to attempt to identify is this particular compound inequality an and statement, or is this particular inequality an or statement? Now, each type of inequality is going to give you two separate situations for a particular variable or a particular thing per se. When it comes to an and statement, and means that it's gotta work within both sets of parameters. So it's got to be this and that. When it's an or statement, it's either got to be one or the other. And normally, when you are graphing these, they have a very particular way of graphing. So if you look at a graph of an and statement, what we're going to have here is two values. I'm just going to call them A and B for this particular instance. Now, depending on if it's greater than or less than or greater than or equal to or less than or equal to is going to depend on if the value gets shaded or not. All right, that depends on the situation. But what will happen is the shading for an and statement is going to be between these two values. And that's where we're going to get the and statement from. Anytime we have an or statement, again, I'll use C and D. And again, whether they're open or closed is dependent on the situation. But with the or statement, they are always going to be shaded away from the other value. So D is going to be shaded this way over here. C is going to be shaded this way over here. So that is typically what a graph of an and statement looks like and a graph of an or statement. Knowing what those are going to be is going to help us determine the consistency of each individual problem. So here it says they want us to write each sentence as an inequality, then they want us to graph each inequality. So for part A, it says a number x is greater than -8 and less than or equal to 4. So the and right here is telling us what the statement is. This or right here is more with the less than or equal to part, so that's not where that comes from. So now we got to graph this. X is being represented by both values. So first off, X is going to be greater than -8. That one's relatively straightforward to answer. And X is also going to be less than or equal to 4. Okay. Now, if you left it like this, nothing wrong with that. All right. This particular answer is called an expanded form. All right, so the answer is expanded, right? It's a compound inequality written in expanded form. Another way of writing an and statement, which is more commonly written, is the condensed form of this particular situation. So the condensed form is you're only using one variable x and it's in the middle. Then you're looking at the two numbers that are being attached to it, all right? So it's -8 and it's 4, all right? Dealing with, number lines and stuff like that, -8 is the smaller number between the two, so that's going to be on the left side, and 4 is the larger number, that's going to be on the right side. The one thing that you have to keep in mind is where are the inequality symbols pointing towards with respect to each situation. So if I look here, the inequality is pointing towards x. So I'm going to do that in the condensed version. In this one over here, the inequality is pointed towards the 4. So I'm going to do that over here. All right. So this is the condensed version of your answer. And for some reason with and statements, this one is the most commonly used uh, way of answering it. Nothing wrong with the expanded form, but this is the way that most answers are given in an and statement. The one thing that I do want to show is when you're looking at this condensed form, do you notice that both of these inequalities are pointed in the same direction? They are both pointed towards the right side of the problem when your smaller numbers to the left and your larger numbers to the right. That is going to be consistent throughout any and statement that we write. So in order to graph this, graphing this is going to look something like this. My smaller number is -8. My larger number is 4. It's an open circle with the -8. It's a closed circle with the 4 because of it being equal to. And the shading is in between the -8 and 4. So that is how we'd write and graph that with an and statement. For the or statement, that we're going to look at here, it says we have a number y is at most 0 or at least 2. So y is the variable in this particular one. So this was A. If we look at this one with B, so the first one, it's going to be y is at most 4. So can it be 4? Yes. So we know it's going to have an equal to on the bottom. At most means can it be larger? No, it can't be larger than 4, so it has to be smaller. So this is where we're dealing with less than 0. We said it was an or statement. That means also y is at least 2. Can it be 2? Yes. So we got an equal sign on the bottom. At least means that can it be larger? Yes. So that means it is greater than 2. So y is less than or equal to 0, or y is greater than or equal to 2. All right, so now this, again, is my expanded version of the or statement. And then for some reason, this one is the most commonly used form for answering or statements. You rarely see it in condensed form, but I'm going to show you what it looks like in condensed form, and you can kind of tell what it looks like with respect to an and statement like we did in example A. So again, you're going to put y in the middle, the variable in the middle, between 0 and 2. 0 is the smaller number, 2 is the larger number. And then the same thing what we did with example A, you're still just going to point the inequality towards what the each particular situation was given to you. So for this one here, the inequality is pointed towards 0, so I'm going to do that as well. This one, the second one here, was pointed towards y, so I'm going to keep that there. It's condensed version. Now, again, do you notice they're both going the same direction, but now they're going towards the left? And so that is another indicator that it is in fact an or statement. And again, if we want to graph this, you got 0 here, we got 2 here. This is a situation where they're both closed circles. And if you look here, my variable is on the left-hand side, the arrow is pointing left. That means that my arrow is going to be shaded to the left over here. When I look at my y is greater than or equal to 2, it's pointing towards the right. That is what we have over here as well. So these are two examples of and statements, nor statements, how they're either depicted either as expanded form, condensed form, and I would take both scenarios. So just make sure that you're consistent with the labelings of the inequality and how they're written, and we should be good to go. The one thing, again, I hate to put it, but I want to be like an indicator, like this is not a way to do it. So like if you ever have a situation where your answers look like this, you have a value A and a value B, and these here are not going in the same direction, this is an indicator that we've done something wrong. All right. And so since we've done something wrong, we have to look back and say, okay, did we read the problem correctly? Did I use, just check those things over. All right. So because these should be consistent. All right. So now here, what we have is a compound inequality, and both of these examples appear to be and statements. So there are a couple different ways you can go about doing it. One of which is to just leave it in the condensed form in which they have it. So what you have to do is this, or what you have to think about it is this, is these are two separate problems. So here, this x minus 2 is going to be attached to both situations. So this is like saying, if you were to expand this, this is like saying negative 4 is less than x minus 2, and x minus 2 is less than 3. That is what it would look like in expanded form. You would do the exact same thing to both particular problems. You're both going to add 2 to both sides. So if you wanted to leave it in this condensed form, what you're going to do is you're going to add 2 to get rid of this. But you're going to add 2 to this side, and you're going to add 2 to that side. So by canceling this, I'm left with x. I dropped down the inequality signs and keeping them consistent because I didn't need to make any changes yet. 3 plus 2 is 5, and negative 4 plus 2 is negative 2. This is my solving the compound inequality, and it's an and statement because it's pointing towards the right side. And when I graph this, I got my negative 2, I got my 5, I got open circles on both of them, and because it's an and statement, we are shading in the middle. Looking at B, we have to do probably a couple things because it looks like it's multi-step. So I'm going to subtract 1. Not only am I going to do it here, but I'm also going to do it there. So canceling out here, I got negative 3 is less than negative 2x, which is less than or equal to 8. Oh, nope, sorry, that's wrong. My bad. This would be negative 4. Sorry about that. Now here, this is going to be dividing both sides by negative 2. Again, remembering the rule about multiplying or dividing by a negative number. I divided by negative 2. So my inequalities are going to be changed. So negative 4 divided by negative 2 is positive 2. This now becomes greater than. This becomes x. This becomes greater than or equal to, and this becomes negative 4. So what I would like you to do is just like what we did with the original and statement we did in the first example with A, I'm going to rewrite this and put the smaller number on the left, the larger number on the right. And if you notice the 2 here, the 2 here is pointed towards, the inequality is pointed towards the 2, so I'll keep that consistent. The inequality with the negative respect with the -4 is pointing towards x, so I'm going to keep that consistent. And if you notice, it's still an and statement because the inequalities are both pointing towards the right. And if we were to graph this, got my -4, got my 2. This is a closed circle, open circle, shaded in the middle. So now here, this is an example of an or statement. More often than not, like I said, or statements are written in an expanded form. The reason why this one's an expanded form is because these two expressions are different. Sometimes when the expressions are the same, they may condense them, but in this particular instance, they're different. The only thing that's similar is they both have a variable of y. So when you go about solving, you're just going to solve these particular inequalities individually. So looking at the first one, adding 5 to both sides, now I got 3y is less than -3, dividing by a +3, so y is still going to be less than, and it's going to be -1. On the second inequality, I'm going to add 1 to both sides, which then cancels. So now I got 2y is greater than 6. Dividing 2 to both sides, I get y is greater than 3. So my or statement is going to be y is less than -1 or y is greater than 3. So when I graph this, I kept the variables on the left-hand side for both. -1 is smaller than 3. They're both either just less than or greater than, so they're both open circles. Looking at this one, arrows pointing to the left. I shade to the left. With the y is greater than 3, arrows pointing to the right, I shade to the right. It's consistent with what an or statement should be looking like when it is graphed. And that is my solution. Here's my graph. So in this particular problem, it says we have an electric device should operate effectively within a specified temperature range. Outside the operating temperature range, the device may fail. They're asking you to write and solve a compound inequality that represents the possible operating temperatures in degrees Fahrenheit of your smartphone. So in your textbook on page 84, they have a picture of a smartphone and it says operating temperature 0 degrees Fahrenheit to 35 degrees, not Fahrenheit. This is 0 degrees Celsius to 35 degrees Celsius. So they give you the Celsius. Now, in example A, they want you to figure out the possible operating temperatures in Fahrenheit. So we have to look at, or we have to remember uh, our formulas for converting. In order for us to convert Celsius to Fahrenheit, we have to use the formula of 5/9 times it by the quantity of Fahrenheit minus 32. So instead of using Celsius, which is technically the temperature range, if you were to write this as an and statement, it is going to be 0 is less than or equal to whatever degree Celsius you have, which is less than or equal to 35 degrees Celsius. So this would be the representation in Celsius, but they want us in Fahrenheit. So what we're going to do is we are going to write this as 0 is less than or equal to, instead of writing this, we're going to write in that. So we're going to, this whole thing. So 5/9 times by the quantity of F minus 32 is going to be less than or equal to 35. So this is how we're going to get our temperature range in degrees Fahrenheit. So here, what I'm going to do to kind of eliminate this, I'm going to multiply 9 over 5. So I got 9 over 5 here. I got 9 over 5 here. So 9/5 times 0 is still 0. So that's less than or equal to. Now what I have is this gets crossed out, this gets crossed out. So I got F minus 32 in the middle. And it's going to be less than or equal to. So if I took 35 times 9 and divided it by 5, I'd get 63. Okay. So here, all I have left is I'm going to add 32 to now only the left side, but I'm going to do it to the right-hand side, which now means that 0 plus 32 is 32. I got less than or equal to. I got Fahrenheit less than or equal to. I got 63 plus 32, and I got 95. So my compound inequality representation with degrees Fahrenheit is going to be 32 degrees Fahrenheit, between 32 degrees Fahrenheit and 95 degrees Fahrenheit. So what do they got here in example B? It says describe one situation in which the surrounding temperature could be below the operating range and one which it could be above. So you're just simply selecting a value that would be below 32 degrees, and you're just selecting a value that would be above 95. And that is being able to solve compound inequalities. Hope this helps. Until next time.